Cloning is the process of creating a copy of a Git repository, but it's also doing two important things behind the scenes that you might want to know about to increase your confidence when you use this command. Say we have an open source Git repository hosted on GitHub. To make a copy, I'll first find the repository's public SSH or HTTPS address. That's typically found on the repository's public hosting page. Copy that address and pass it to either the git clone command in your terminal or in your IDE. When you execute the command, Git will communicate with the hosting service, download and extract that repository to your computer. Just like that, we end up with a repository clone complete with all the source code and history of that repository. But what did Git actually do to make that happen? Let's dig first into the most important thing to know about clone, the .git folder. Git works by storing file history and other repository metadata in a special database of sorts, which can be found in the root of all Git projects in a hidden folder called .git. Without this special .git folder, all that lovely version control functionality like branching, diffs, and history wouldn't be possible. But if you're curious about more of those behind the scenes mechanics, you've been watching a snippet from the Fundamentals of Git lessons on my learning platform, learngit.io. Anyways, when a repository is cloned, behind the scenes, Git actually creates an empty directory on our computer, downloads that .git folder, then extracts the latest versions of all source code files into that empty directory. Interestingly, if you only care about duplicating the source code, but didn't want version control, it's perfectly okay to go ahead and delete that .git folder after cloning. You'll save space on your computer, but sacrifice version history rollbacks, branching, and other version control functionality. But here comes the second most important thing to know about clone. Most folks will want to make changes to a clone repository and contribute those changes back to that same remote repository. Fortunately, clone did a second important thing behind the scenes that makes this possible. It linked the cloned copy back to the original source repository using remote reference pointers. Think of these pointers like bookmarks that keep track of the remote repository's location. When another person contributes changes to a remote repository, any sync operation, like fetch for example, will update these pointers in your local repository too. These pointers are absolutely critical for Git operations like push and fetch to work correctly. And if you ever wanted to see these pointers for yourself, try running git remote-v or git branch --all. Here you'll find a list of all these remote references. For me personally, understanding these pointers was the key that helped me finally understand how to untangle merge conflicts that unfortunately are all too common when pushing and fetching changes, especially when your repository has multiple contributors. If that sounds like a topic that interests you, you can check out my video on pull and fetch. In that video, I'll go into a lot more depth about these pointers and how they work. You can also check out the collaboration lessons on learngit.io. But for now, I think that's all you need to know about clone. I'll see you in the next one.